Welcome to my channel. Let us look at this question. Compute the first derivative and the second derivative for the following set of parametric equations. So x is equal to 4t cubed minus t squared plus 7t, and y is equal to t raised to the power 4 minus 6. So for us to do that, we have to obtain the derivative of x with respect to t and that of y with respect to t. So it means we're going to solve for the x dt, and that will be 12 t squared minus 2t plus 7. That is the x dt. Then the y dt is going to be 4t power 3. So after that, we can now get the first derivative, that is dy dx, by taking dy dt over dx dt. So we're going to have that as dy dt over dx dt. So dy dt is 4t raised to the power 3, and it is over dx dt, which is 12 t squared minus 2t plus 7. So that will be the first derivative of those particular parametric equations. So we can also look for the second derivative. And for the second derivative, we are going to need the derivative of dy dx first. So dy, the derivative of whatever we obtain there, that is dy dx. So this is what we have. So we are going to take dx of this. That is 4t cubed over 12t squared minus 2t plus 7. So here we are going to use the quotient rule, because it is a fraction between two functions. So we're going to take the derivative of the upper function and multiply by the lower function. So that will be, if you get the derivative of this, it will be 12 t squared times this function, that is 12t squared minus 2t plus 7. Then we're going to subtract the derivative of the second, or of the denominator. Then you multiply by the first function. So that will be, and the first function is 4t cubed, and we're going to multiply that by the derivative of this one here, which will be 24t minus 2. Then whatever we obtain, we divide by the square of the denominator, that is 12t squared minus 2t plus 7 squared. So let us simplify this. So we can open up that bracket so that we have 12 times that, which is 144 t raised to the power 4 minus 24 t cubed plus 84 t squared minus 96 t raised to the power 4. That will be plus that times that is 8t cubed, and that is over 12t squared minus 2t plus 7 squared. So we could simplify this further, so that we have, we can collect like terms. We have the one with power 4. If you get that difference, you are going to get 48 t power 4. Then the power 3 is that and that, which will be minus 16 t power 3. And we are left with the one with the power 2, which will get to be 84 t squared. and that is over 12t squared minus 2t plus 7 raised to 2. So now that we have the ddx of dy dx, we can now get the second derivative. We can now get that second derivative by taking this particular derivative and we put it over dx dt. So this will be the same as just take the dx of dy dx, then divide that by dx dt. So let us do that. That will be equal to, this is 48 t power 4 minus 6 t power 3 plus 8 4 t squared over 12 t squared minus 2t plus 7 squared, and that is over what we found for dx dt, which was just 12 t squared minus 2t plus 7. So if you work this out, you'll have that to be 48 t power 4 minus 16t cubed plus 84 t squared over that times that, which is just 12t squared minus 2t plus 7 all raised to power 3. Thank you for watching. If you found this video useful, please subscribe.